Hello, Chris Sexton here, Team Heli Pros. Welcome to this third build video on the SAB Goblin 700. Tonight we are looking at the tail and this beautiful boom. We're going to be building the tail box, setting up, getting going through the head, making sure all the thrust bearings are lubed properly and all loctated back together. We're going to take a real close look at this tail pulley. This is a point of contention for some people. I'm going to check these bolts in this aluminum, make sure they're tight. This looks like it's pretty beefy. I don't see any signs of weakness in these flanges, so I'm thinking this might be the fixed tail. Not sure. Someone can correct me if they know, obviously, by looking at it, if it is or isn't. But it looks solid to me. I'm going to run it. And then we're going to start putting the tail together. I'm probably not going to video pulling this apart. If I get this tail assembly apart and find something way wacky, I'll video it. But according to the manual, it's pretty straightforward. Thrust bearings and radial washers. There's nothing really reinventing the wheel here. But I am going to pull all the way down, double check the lube and everything, double check the Loctite on everything. Again, if I don't do it, I don't assume it's been done. So when we come back, I'll have the head back together in this stage, but assured that it's Loctited and greased. I'm going to go ahead and put the ball, pull this off, make sure that's good. I'm going to put the ball on the crank, the bell crank. When we come back, I'll be ready to start piecing together the tail box. Oh, one last thing before I forget. I remembered to take the motor with me to work. Got the end of the shaft taken care of there, and that is ready to go. So we are ready to get this tail on this bird tonight and hopefully start placing electrons. Okay, got the tail crank pulled apart. There's a spacer in there, nothing special, some radial bearings, no Loctite on there, spins nice and free. It's actually one of the freer moving bell cranks I've seen. Got the ball on, a little Loctite on there. Again, nothing's terribly fancy, but it's definitely good quality aluminum. I think that was going to hold up well. I did get the head back together. I didn't find absolutely anything out of the ordinary. You've got pretty straightforward radial bearings in here. Piece of cake, really. Wasn't difficult at all. You know, thrust bearing, inner radial bearing with thrust bearings. The hub is threaded. There's a notch in the spindle shaft for the set screw. Make sure you get that lined up. I use blue Loctite on that. One trick, and I meant to videotape this and I apologize. These were all Loctited from the factory, but again I pulled it apart. I've had problems where you Loctite the bolt and try to put it together. Loctite gets up here into this brass and then this binds. So what I've learned over the years, I don't remember where I read it, but I actually put Loctite on the end of a really small Allen and wet the threads of the bolt of the grip rather than the bolt. So as it's pushing the Loctite through, there's nothing seeping out and this getting into the brass, and then that's going to set up and be absolutely liquid smooth. I mean, that's a very, very well built tail. I'm sure that's going to be great. Can't help but notice the massive divot for the set screw for this pinion, for this belt pulley. That's going to be really easy to key and get solid. I like that. Up next is the actual tail case. Now, to do the tail case, we've got to do a little prep work. We've got some spacers to put on. There's some prep work to the boom we got to do. So I'm going to go ahead and cut the camera and get some of that prep work done. And I'll be back. Got my initial prep work done. I've got the pivot point for the bell crank mounted. Those go with some nice 3x8 bolts. I've also got the 4 upper supports for the tail case in and ready to go. Make sure when you build this tail case you got the flange joint so it's being captured by the tail pulley. So the wider part is the inner part, so only the bearing comes through. This flange has to be on the inside, and that's going to line up to this guy. The next step is going to have him put the belt on the pulley and kind of do the assembly here, which is going to get the basic belt tail structure with the belt hanging out there, and then the boom just goes in there. So the prep is pretty much done. So I'm going to go ahead and cut the camera and get the tail on, get the pulley on, get the belt on. When we come back, I'll have the tail case together. Ready for the boom. There it is. Tail box is built. Belt is on. I was careful to coat the threads on that set screw very well, but yet not be excessive. I don't want it gooping out, but that set screw's not going anywhere. This tail is just so... I got to be careful when I'm setting up the tail on this. This slider will allow it to travel too far and bind. So to comes electronics setup. I'll have to keep that in mind. Does not need the full throw for sure. But it's pretty solid. This is 3 mil carbon on this tail fin and the right side of the tail box. The boom's going to come into here, and you've got some, this is where the belt tension is adjusted. The primary tension is set there anyway. There's a little bit of tension on the idler up front. That's going to go through there. And before we can do that, though, I've got to do some prep work to the boom. So I'm going to stop there, get the boom out, do the prep work on that, and then when we come back, I'll be ready to put the boom into the tailcase. Okay, begin the prep work on the boom. I'm going to start with the tail control guide. It's kind of the easiest thing that we do first. This has to go through here and held in place, and the screws go down through the boom. Rather than sit here and fight and leverage it, I suggest you actually start the bolt into there on the table. It's much easier to push down like that to get it started than fight with it. Don't go all the way through. You want the threads to be tight, and obviously you use a little CA on those threads too. But by doing that, you've opened up the first couple of threads. It should start a lot easier, be a lot less of a fight to get them started. So I'm going to go ahead and get that on. Then it has you take this double-sided tape, and then these are actually not only reinforcement plates for this, but they're also the nylock nuts for the tail case. It's for the tail adjustment on the belt. Those get glued to the double-sided tape to the inside of the boom. I'm going to do that, and then when I come back, we'll be talking about setup on this tail servo. Okay, I'm working on the prep of my boom. I got the tail control rod brace installed. Little C on those screws. Do not over tighten those, because we don't want to crack the paint. You don't want to strip them out. It's just got to hold it. It really shouldn't be a whole lot of pressure on it anyway. Then it has you take these frame braces and screws that glue to the inside of the boom. Those do two things. It braces the area that the tail case bolts to. It also captures the nylock nuts that they screw into. Now, I was really worried about how I was going to get those in there and lined up. Then it just occurred to me. I applied the double-sided tape to the actual CF first, and then kind of eased it up in there, and then drew it down tight with the actual screws that hold the tail case. That bolted in square, got some pressure on there, let the double-sided tape set up, then I just back these screws out, and now I know it's lined up. They turn easy, the nylock nut can do its job, yet the double-sided tape is holding that CF brace in place. Piece of cake. Now I'm going to go ahead and drop in my tail servo. I gotta install the brace that goes here, and this boom will be about ready to put the tail on the tail case. Okay, on. This next step has you take this frame brace, which goes in here, put it in there, and then this is basically a turnbuckle. It's got a threaded rod in there. You tighten it all the way down. They want you to put CA on this flat surface, and then you put it in there and you twist this until these studs come through the carbon fiber. But then you want to put pressure on this so that it actually keeps the boom square, that keeps it from compressing there. The CA holds the metal so it doesn't vibrate and chafe. And then when it's all said and done, you put these shafts in with spacers and a nylock nut, and that's what holds this brace in the lower part of the boom into the frame when it's all said and done. It's actually not too difficult of a project. Just run it all the way in. I'm going to put CA all the way around the flat spots here. Careful not to get it down into the threads. Put it up in there and just lightly loosen it up until the raised shoulder there comes through the CF, and there's pressure, so it holds itself there, letting the pressure from these two braces on that threaded rod hold pressure on it. Of course, I'm going to put some Loctite on this threaded rod, so when it all sets up, it's solid. And should keep the boom very well supported there, and give us a place to help mount the boom to the CF. Piece of cake. Alright, there it is. Brace is in, tight. Studs are on, lock nuts are in place, and leaving those loose, because obviously the CF frame's got to slide under that washer, but that actually wasn't too bad. I was expecting it to be harder than it was. My boom does have a little bit of carbon fiber inconsistency there in the corner where the brace goes in. It doesn't appear to be affecting the structure, but it is a little bit. There is a little bit of an issue there that I missed on an initial inspection, but you know, cosmetically it looks fine. Structurally, I think it'll be fine. So we're going to keep on plugging away. Next, I'm going to go ahead and get my rudder servo down in here and mounted, and then I'm going to talk about how the wire's got to run a certain way. You've got to have the servo wire coming through here underneath this brace. and kind of pinned up out of the way. Can't be allowed to get up into the path of the belt, obviously. I'm going to talk about that. Get the servo in, and then this guy will be ready to put the belt and tail case on. Alright, well, I got a little ahead of myself. I got really into it. It just kept on plugging away and forgot to stop and update the video, so I apologize. But the boom is basically done. I'm going to tell you, I was really expecting this to be kind of a chore. Big bulky boom, getting these screws lined up, getting the servo in to get the spacing right. It really wasn't. This is just a pretty well thought out idea, I think. The control rod, they give you quite a bit of adjustment. I put mine exactly at the specs. I left 15 millimeters of thread rod, 15 millimeter thread rod exposed here, 15 millimeter here. Let the CA set up, and then I spun all my links. I got my bell crank at 90 degrees, which puts my rudder servo at darn near 90. Which of course is giving me a couple of degrees of natural pitch, which is, counteract the, that's a rate mode setup. It should be good. I'm going to test it in rate mode when I go to fly it. But it's pretty good. I did want to talk about, they make a special note in the manual, and this is going to be really hard for you guys to see on camera, and I apologize, but the wire on the rudder servo has to stay up against the side of the boom. It can't be allowed to drift down into the path of the blade of the belt, or you could have problems, obviously. So I just put a little bit of double-sided tape down there to hold it down, and then took advantage of these extra holes here. Those holes are used for tightening this plate, but I'm using them just to gently use a zip tie to help hold that wire down out of the way. Shouldn't be a problem at all. Lots of room. You've got what appears to be darn near a ½ an inch of adjustment on the tail case for the belt. Plus you've got a little bit, a very little bit of adjustment at the front when you put the frame together for the belt, and then the whole system's got that spring-loaded idler. So the belt tension shouldn't be too bad, too hard to set at all. Nice big 27 tooth tail. Got a lot of those teeth engaged on that belt at once. No wonder these things have no problem with tail authority. There's no way that belt can slip. It's really well done. It looks good, put together. It's real low profile. I like the rudder servo being where it is. It makes it nice and clean. This center guide was kind of a pain to get those screws in, but it does its job. Everything moves real well. They do say in the manual that you want your offset from the center of the rudder servo to the ball to be between 16 and 18 millimeters. Mine is right at 18. The next knob in, hole in on this particular arm dropped down to just a hair under 16. So I'm hoping it's good where it is. If I have resolution issues, I'll play around with it, maybe try to find a different ball. But yeah, there's the tail boom all together. Looks good. Makes a nice solid, very solid tail on this. Coming together well. Tell you what we're going to do now, though. I'm going to clear off my table, pull out the servos, and get them plugged into the V-bar and centered. The next step has me go ahead and put the servos, cyclic servos on, and get the swash plate and everything level. So before I can do that, I need to get my V-bar initialized and the initial settings done. I'll probably take a couple of quick moments to explain how I go about setting it up, but this is pretty straightforward. Anyone who's ever seen Burt Kammerer's Smack Talk RC setup tool for the V-bar, I literally do it his way. I stay everything out on the table. I use a receiver pack to power everything up. I plug it into the computer, turn everything on, bind it, do all the travel adjustments in the TX to make sure you get maximum throw in the 5-arch controller, and then I will arrange the cyclic servos in the order so I can label them 1, 2, and 3, so I know which ones go to where on the cyclic. Get them to their center position, and then put the servo arms on, so that I'm as close to mechanical 90 on the servo arms as possible. I really go the extra effort to try to make sure I have a mechanically level swash. So step one of that is starting electronics off right, and that's where I'm at. So when we come back, I'll have all the electronics spread on the table, and I'll just really quickly, visually show you what I do with this. Alright, here we go. I have, as I said, laid out everything on the table. I've got my cyclic servos. The rudder servo is already in the tail. I'm going to make sure that the V-bar knows that it's a 251, 750 hertz servo, so it will center. and then I could adjust it from there once it's all together. But cyclics are the ones I want to make sure are as close to mechanically perfect as possible at this point. So I've got my cyclic servos. I am running DX8, so I've got DSM-X satellites. I have my V-bar set to accept DSM-X satellites. All bound up, ready to go. I have figured out I am going to run my gyro servo underneath there's an optional tray in the back that you can use for single unit gyros without RX. I'm going to run that, put the gyro underneath it and the Fiberwash controller on top. So I've got my gyro set for upside down, wire towards the rear. That will make sure my orientations are correct for compensation for yaw and whatnot. I've already gone through and set up my TX to make sure that I have maximum travels, set up the centers are correct. I did that before turning on the camera because it's kind of tedious and boring. Again, this isn't a video about how to set up V-bar. Everyone flies it. There are so many different kind of Fiberwash controllers. I've flown most of them. I prefer V-bar. That's fine. If you want to know how to set up V-bar, shoot me a PM. I'm more than happy to give you a link to the Smack Talk RC. It's the best $3 I ever spent when it comes to setting up V-bar. So this is my basic setup. I'm going to go through now off camera and set my servo arms, get them on, get the balls on, get them mechanically centered. And then when we come back, I will be putting the servos onto the heli because that's what's next. But I needed to get the arms centered before I did that. All right. Well, I apparently got a little ahead of myself and had 2 pages stick together, and I put my servos on before mounting the transmission onto the mainframe. So I'm going to go back and do that now, but I will take a second. This makes it easier to show it to you. These servos, it's definitely a direct-to-swash, piece of cake. Again, they recommend a servo with the ball at 16 to 18 millimeters. I'm really hoping 18 millimeters comes out good on the resolution because I had these Align Futaba metal arms. The plastic arms I had are going to be 19 or 13. And if 18 works out, then I'm cool. If it ends up not being quite enough resolution, I'll pick up some plastic Dupros or something tomorrow. But I'm hoping that works. I have to redo these servos twice. But got them all mounted. In the V-bar world, I'm going to turn this up so this is right side up with you. Channel 1 is elevator, which is here. Channel 2 is left side aileron, which is here. And channel 3 is right side aileron, which is here. All the pivot points are towards the middle, which is why I like the idea of having these metal arms. Plastic ones I was going to have to trim quite a bit to have clearance to move, even though this aluminum is notched for the pivot point. For the servo arm, I like if these metal ones work out with the 18 millimeters balls for resolution. It's going to be great because I know I've got a solid connection. I get real worried when you trim plastic down that much. I just worry it's going to mess with the strength, the structural strength of this arm. So, but that's there. Servo wiring, obviously not going to need any extensions. It's just going to there. It's going to be a piece of cake. I'm going to go ahead and get this transmission in the main frame, and when I come back I'll have this mounted and show you what it looks like. Well, there it is. Transmission's in the frame. Servos are on it. It's pretty nice. No interference on any of the gears. Like I said, you need to preload that, but they notched the frame so that has room to come through to preload. That's neat. Obviously, putting the transmission in fixed the rigidity, the flimsiness of the upper part of the frame. Obviously, the motor mount's yet to go here. It's going to slide in there like that. It's going to go in there. Coming along rather nicely. I'm going to have to say this has been a really smooth build. Other than the really minor cosmetic issue on the inside of the boom towards the end, and I don't think it'll be a structural problem. I haven't had any quality control issues, so that's great news. Next we get to start, go back to where I was since I was in the wrong place. Next I get to build the head linkage. It wants me to go ahead and get the head on there, start wiring electronics before putting the boom on. That's not a horrible idea. I'm gonna take their advice on that, so I'm gonna take a second and get the plate on. I'm going to figure out where my electronics are going to be. Probably go ahead and do that. I'll do the head last. I'm sorry, I'm thinking. I'm going to do the actual head linkage last once the bird is together. So I'm going to go ahead and put the boom on, get my gyro tray on, get the motor on, get the ESC mounted. Probably mount the ESC and the motor before I put the boom on, just for not having the big boom, bulky boom flailing around. I do need to put the boom on before I put the gyro tray on, so otherwise I would do the boom absolutely last. So I'm going to go ahead and do that, and we will do the head setup and the probably call that a night actually once I get the boom on it, and then I'll actually do the linkage and the actual leveling of the head tomorrow. So stay tuned. Guys, well, made a lot of progress. I have the transmission mounted, servos mounted, servo ball arms on, Loctited, motor is on, belt is on, tension is set. This is actually a pretty simple system to set the tension on. I didn't videotape it, but I'll talk about it real quick. Basically, there are two springs in the end of this motor mount. You push the metal mount all the way in, fully flex the springs, and tighten one of these slide points. That'll hold the blade in, the belt in for you. I took this carbon fiber belt protector out so I could slide the belt on with it in. Once you have the belt lined up and around the pulley, you loosen the slide and the springs will pull it out. Instructions say to give it a little bit of a pull, not a whole lot. You don't need to overstress this, and then snug it back down. There are 4 places to snug. You got the 2 slides here, and there are 2 slides here. Basically, that belt is on a guide right there. It can't walk up and down. They have you spin it a few times by hand just to make sure it's not walking. It's pretty much, you can't really see it, but you can feel it. There's just a fraction of a millimeter gap between the bottom of the belt and the bottom of the tooth. So it is fully, the gear is fully contacting the belt. Spin it by hand several times. It's not walking around. That really should be good. And as you can see here, the one-way works just fine. So I did that. Then I went ahead and started playing with electronics. I have already mounted my ESC. Like I said before, I'm using the Scorpion 130 volt, 130 amp. Fits in there perfectly. I've got the, I programmed the ESC prior to that again. Nothing rocket science there. It's just set to the fastest response time, aircraft mode, external governor. And then I've got the phase sensor wire plugged in there. I put a little heat shrink on it so it makes it harder to pull apart. And so the ESC is mounted. I have done a quick trial mount of my V-bar. I did decide to put the V-bar sensor underneath the transmission where the instructions recommend. Just make sure it's not touching any of the sidewalls. Try to isolate it from vibes, but I think it'll be good. Then I'm just going to put this against the side here. I'm running SATs. Won't have a separate RX. It's going to make it pretty clean. I'm going to call it a night there. The next thing I have to do is put the boom on. I need to put the boom on, and that way I can finish running the servo wires, tighten down the servo wires, and then make an ultimate decision. I keep waffling between using a Beck Pro 2 or just running a Lifey receiver pack for 6 volts. I'm not sure. I like the clean look of the BEC. Where the ESC in this guy is located, if I run a BEC, I'm going to have to extend my BEC power wire to come out here so I can grab the power. I don't know. I'm still kicking that around. I'll make a decision on that tomorrow during the day. But all that's left, I know it looks like it's in pieces. The boom is together. All that's really left is to put the boom on, run some servo wires, power the system up, and program the head. We are really close to being done. I have no problem believing I'll get her done tomorrow. It's just, it's getting a little late tonight. So I'm going to go ahead and stop here. Gives me time to produce the video, get it uploaded before I go to bed. And there will be a 4th video, but that doesn't surprise me. I thought there would be. When we pick up tomorrow, I'll have made a definitive decision on my BEC, where to put it. You guys have a great night. Thanks for tuning in.